All right, here we go. This is another theory question. It won't take long to explain it. But again, I'm going to add some numbers, and we're going to actually work this through and see what the actual answer is, which will be good. It says 2 boxes on a horizontal frictionless surface. One box has a mass of 40 kilograms. That's labeled already. The other box has a mass of 10. The 2 boxes are connected by a light horizontal rope with a tension T. A force F is applied to the 40 kilogram box. Now let's make that force F 80 newtons. And the 2 boxes move along surface. Which statement is true? Okay, I want to see if the tension force is greater and less than the 80 newtons. Well, I already know the tension is going to be greater than the 80 newtons, so the answer will be B. But applying some numbers to it, we can work it out and prove that. Okay? All right, so what we need to do is find the acceleration of the boxes. It's frictionless surface, so I don't have to worry about friction. And the best way to find the acceleration of the boxes is to combine them into 50 kilograms. We got a force of 80 newtons this way. We have mg going down. That's 50 times 9.8, which will be 490. We have a normal force going up. Okay, there's no friction, so we don't have any other forces, but we do have to have an acceleration, or the thing will be unbalanced. All right, so now I can come through and do some of the forces in the y. There's no angle, so no components, so I don't have to worry about that. Okay, it'll be ma equals up minus down. All right, now it's not accelerating up and down, so 0 equals normal minus 490, so I get my normal force equals 490. Now, this isn't really a concern unless we have friction. We don't have friction, so this isn't going to get used anymore unless I ask for it. Next step would be friction. We don't have friction, so I get to skip that, so I go to sum of the forces in the x. That's ma equals right minus left, so 50a equals 80. Now, there's nothing to the left, so it's just 50a equals 80. And I come in here and do 80 divided by 50, and that'll give me my acceleration is 1.6. Now, this 1.6 meters per second acceleration is for this and this. So the acceleration here is the same acceleration on each box. Okay? Now that I know the acceleration of the box, I can come over here and work only with the 10 kilogram box. So the forces are mg, which is 10 times 9.8, or 98. We have a normal force going up. We have the tension in the boxes this way, where there's no friction, so nothing opposing, and we have an acceleration of 1.6. Okay, so again, going through my steps, I can do sum of the forces in the y. It's ma equals up minus down. There's no angle, so no components. Okay, so 0 equals normal minus mg, which is equal to 98. So I get my normal equals 98. There's no friction, so I skip that step. So sum of the forces in the x, that's ma equals right minus left. I do have an acceleration 1.6. I have a mass of 10. So 10 times 1.6. Now, they're both pointing to right, so they're positive, so I leave that positive. Equals to the right is my tension, and there's nothing to the left. So 16 is equal to my tension. So you can see the tension does come out a lot smaller than the force here. Okay? Hopefully that helps. It explains why the answer is what it is. And I'm on to my next problem.